we are now going to look at water balance. Water balance in the body. Now, people, remember that 90% of your blood plasma is made of water. So we must make sure we have enough water. Otherwise, our cells will dehydrate and we will die. Okay, because the water will move from the cells into the tissue fluid and into the capillaries, into the blood. It will be pulled out if there are too many solutes. In other words, not enough water, hasn't been dissolved enough. When there is too much water, we swell. We have what's called edema. So we will swell, our organs won't be able to work properly, and it's because your kidneys are supposed to do the job of cleaning your body out. But the kidneys are the target organs. So they do the job. They need to be stimulated to do the job of either removing excess water or keeping water in the body. The difficult thing with water balance is it's not only what you take in versus what you put out in the form of sweat, it's that your body needs water to clean itself and function properly. So we need to look at not just the way the kidneys work, we need to look at the link between the hypothalamus, our CEO, the hypothalamus, with the with the pituitary gland, because remember the pituitary gland is the master gland, and the hypothalamus will tell the pituitary, listen, bud, there's too much water in this blood. Too much water is bad. You don't want too much water, because if you have too much water, you're going to pull solutes out of your cells, okay? But you're also going to end up with cells that are now going to sit with taking too much, and the cells will burst, okay? It's called, when they burst, I can't think, I've just gone blank, but they burst, all right? Whereas lysis, I can't remember, something lysis, but I've gone completely blank. Guys, send it to me because I can't remember. But your cells will burst. And if there is, if there's too much solutes in the blood, and that's going to then take the water from the cells, and the water is going to move out by osmosis from a higher to a lower water potential along the concentration gradient through a selectively permeable membrane. Remember osmosis. So the water will move out of the cell, and then what's going to happen? The cell will shrivel and shrivel and shrivel and shrivel and just die. That's called crenation. And I still haven't thought about, I'll remember what the word for a cell exploding. Cytolysis? Cytolysis. Okay, so water balance in the body. This is how it works. It's a schematic, and if you know the schematic, you can explain either of it. So we're going to start with here. Okay, and this will be a normal water level in blood. Okay, there it is. It's normal, but it doesn't stay normal. Let's say the water level decreases. Now, when would the water level decrease? Let's think. It's very hot and we are sweating a lot, okay? Or if you were mountain climbing and you were walking a long way but you forgot your water bottle back, so you're exercising, okay? You are going to lose water. Your body gets hot, you're going to sweat to cool it down. Doing any kind of exercise, your body uses water. So we want to make sure that we now correct the problem, and we must make sure that we keep water in our body. So the hormone, antidiuretic hormone, which is the hormone we're going to talk about now. Anti means against. Diuretic means to wee. Okay, so it's literally an anti-weeing hormone. So when would you not want to wee? When you want to keep water in your body. And if you're keeping the water in the body, but you must still get rid of wastes, you're going to end up with concentrated urine. All right, so this is how it works. To start off with, we're going to say, right, we're going to have our learners that are going for a walk or they're exercising. So the water level in the blood decreases. Okay? Decreases. And when it decreases, we say that the water is, or you become hypertonic. Okay? Hypertonic because there are more solutes and less water. Your water level decreases. Okay. Next point is that this low water level is going to be picked up by hypothalamus. And what does the hypothalamus do? It then sends impulses to the pituitary. Okay, so low water level, the level it decreases. This low level is picked up by the hypothalamus, which is part of the central nervous system. And the hypothalamus will then send impulses to the pituitary gland. So what happens then? The pituitary gland is stimulated to release more anti-diuretic hormone. It's the anti-weeing hormone, your anti-diuretic hormone. The anti-diuretic hormone travels in the blood because it's a hormone. And where does it go? It goes to the target organ. And the target organ is the kidney. And it says to the kidneys, listen guys, we need you to now become more permeable to water so we can keep the water in the body, and you are going to have to make more concentrated urine. So the kidney, and in the kidney, ADH causes permeability. Permeability means the ability of the water to move through a membrane. The permeability of, oh man, see, when I'm talking and I'm writing, I make a mess. The permeability of collecting ducts, okay, and distal tubules. Now you did all of this in grade 11, guys. Okay, tubules to increase. Now remember, the more permeable the collecting ducts, the collecting ducts and the distal tubules are, the more they're going to take water out of the tubule into the capillaries. And it goes into the capillaries, it means that your blood, the water level in your blood is going to increase. All right. So we're trying to now reabsorb as much water as we can. Your digestive system absorbs. Your kidneys reabsorb because the water's gone in through the Bowman's capsule. All of it goes in. We now have to take all the good things back. But it's anti-diuretic hormone that is anti-weeing. It wants to keep the water in the body, so it makes the collecting ducts and the distal tubules to become more permeable. And that is going to now increase hugely. And the result of that is going to be that we have more water is reabsorbed. And that is reabsorbed back into the blood. Sorry, back into blood. Okay, so it's back in the blood, and therefore we are going to release more concentrated urine. Okay. That is why when it's been a very hot day, or when you have done a lot of exercise, let's say you've gone and you've played a game of soccer, or a game of netball, or rugby, or whatever it is that you play, or you've done a cycle race. When you go for a wee, first of all, you're not going to wee a lot while you're busy. Why? Because your body's so busy working, all right? And you're sweating, you're cooling your body down. But when you finally go for a wee, and I'm going to say a wee, when you go to urinate, okay, but it's to make a wee. When you go and make a wee, what happens? Your wee smells like bad because it's got a lot of waste products in a little bit of water. Your wee is concentrated. That's also why, for example, at night, you sleep for 7 or 8 hours. Okay, and then when you wake up in the morning, you go for that first wee of the day, your urine is dark. It's dark, and you can smell your urine. That is because during the night, you haven't been drinking. So your body's job is to keep water inside it, which means that your target organ, your kidneys, have now been filtering out all the rubbish while you are resting. It's filtering out all the waste products, and it's reabsorbing the water because you're not drinking while you're sleeping. So that's why your urine is so concentrated, and you can actually smell the urine, that urine smell. The same applies if you drink alcohol, okay? When you drink alcohol, you're going to have a decrease in your water level. Why? Because your body has to get rid of the alcohol. It's got to flush it out. And we're going to have the opposite happening because you're going to end up with a lot of water in your system, and the alcohol is now going to cause your water level to decrease because you want to urinate all that alcohol out. And it's going to be the opposite process, and that's what I'm going to show you now. So let's just recap. Blood, the normal water level in the blood, the water level decreases because you're sweating, because you're doing exercise to cool your body, or at least sweating to cool your body down when you exercise, or you haven't been drinking. So no drinking, sweating, so you've lost water. Okay? What happens? It's picked up by the hypothalamus because the hypothalamus has the sensors. Then the hypothalamus sends impulses. Why? It's part of the central nervous system. So it sends impulses to, let me use another color here, to the pituitary gland. It stimulates the pituitary to release more antidiuretic hormone. It's a hormone, so it goes in the blood. And it travels to the target organ, the kidneys. And ADH causes the permeability of the collecting ducts and the distal tubules to increase. And what results? We have more water is reabsorbed back into the blood, and we release more concentrated urine. So little water plus lots of wastes. Okay, that will be an easy way to remember it. Now, we're going to go exactly the opposite. So here, we had the water level decreasing. Now, we're going to have the water level increasing. So let's use yellow. So what happens? Water level increases. Okay? Now, if the water level decreases, so there was less water and more solutes, we said that that was hyper, then this will be hypotonic. Okay, hypotonic means that we have lots of, at least less solutes, plus more water. So everything's diluted. Okay, next step. So if we look back at this is why it's always nice to learn as a schematic. Here, it's picked up by the hypothalamus. Oops. It's picked up by the hypothalamus, and it is going to send impulses. It's going to send impulses to the pituitary. So here we go. So, hypothalamus is stimulated. Okay, stimulated, and what does it do? And sends impulses to pituitary. So now what happens? Well, the pituitary gets these impulses, and the pituitary, being the master gland, now has to respond. So the pituitary is inhibited. Because of these impulses from the hypothalamus, it's inhibited from secreting antidiuretic hormone. Therefore, we have less ADH into the blood. Okay, now we go back here. More ADH meant we increase the permeability. So if we have less ADH, this travels in the blood, it is going to decrease the permeability. So target organ, kidneys. Okay, and here ADH causes permeability of the collecting ducts and distal tubules to decrease. Now, if that has decreased, it means it's not reabsorbing a lot of water. So what happens? You've got lots of water that can now go into the urine. So we have less water is reabsorbed into the blood. Therefore, we have more dilute urine. Okay, the urine's going to have lots more water in it. And that is like at the end of the day, when you've now been taking water in all day and you've been drinking tea and coffee and heaven knows what else, which has got caffeine, which is also a stimulant, but we won't go there. What happens? You're going to find that your urine, that last wee of the day, you're going to find your urine is almost like water. If you've had enough liquid, if you've had enough water. If you haven't, it's going to be concentrated. Then you know you need to have a glass or two of water before you go to bed. And takes us straight back up to normal. So let's quickly recap. We'll do blue here. It's easy. The water level increases, so it's hypotonic. Okay. The hypothalamus is stimulated again, and it sends impulses to the pituitary, and it inhibits the pituitary, which means the pituitary is now going to release less antidiuretic hormone into the blood. The target organ, the kidneys, it's going to cause the permeability of the collecting ducts and the distal tubules to decrease, which means a lot of water stays. Let me move this up a bit. Therefore, water stays in the tubules, and then it goes to the bladder and then out through the urethra. Out, gone. Okay, so we have less water is reabsorbed into the blood, and we have more dilute urine, not concentrated urine like we had here. Okay, folks, you know what I think I'm going to do? I'm going to give, I've got a table which I've done, a schematic. I'm going to take a photo of it when I get home, and I'm going to post it onto our Facebook page, and you'll be able to access it there. So then you can learn that, and if you know it, in fact, if you only know half, so you only know if there's a decrease or only know if there's an increase, the opposite applies to the other way.